Rare earths has been a very hot topic recently. What are rare earth elements? According to International Union of Pure and Applied Chemistry, rare earth elements include scandium, yttrium, and lanthanide. Rare earths could be classified into two groups, light rare earths and heavy rare earths. Light rare earths, which include lanthanum, cerium, praseodymium, neodymium, prometheium, samarium, europium, 7 elements. Heavy rare earths include gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, yttrium, and scandium, 10 elements. Gadolinium sits at the boundary with exactly half-filled 4f orbitals. Some researchers classified it as light rare earth. Scandium and yttrium are considered rare earth elements because they exhibit similar chemical behavior as lanthanide to some degree. Light rare earths have larger ionic radius, lower density, and a lower melting point, usually more abundant in Earth's crust, while heavy rare earths have smaller ionic radius, higher density, and higher temperature performance, and usually much rarer in Earth's crust. Besides IUPAC classification and definition, metallurgists have another type of definition and classification. Rare earths are divided into 3 groups: light, medium, and heavy. Light rare earths include lanthanum, cerium, praseodymium, and neodymium. Medium rare earths include samarium, europium, and gadolinium. Heavy rare earths include terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, and yttrium. Scandium and prometheium are not considered as rare earths because scandium's chemical behavior is between aluminum and lanthanide. Prometheium does not occur in nature. Are rare earths really rare? Yes, in terms of extractable concentration. The rare earths exist mainly in certain countries, for example, China and Brazil. In terms of total deposit amount in the Earth's crust, rare earths are not rare compared to precious metals. For example, cerium, the most abundant rare earth, concentration is about 60 ppm, which ranks 25th in all 78 common elements, which is higher than copper, about 50 ppm. Thulium has the lowest amount, about 0.5 ppm, which is much higher than gold, about 0.004 ppm. China almost monopolizes rare earth production. Most heavy rare earth deposits are geographically concentrated in South China and Myanmar. China dominates the extraction and processing of heavy rare earths. According to Benchmark's Rare Earths report, in 2023, China was produced about 99.9% of global processed dysprosium and about 80% processed praseodymium neodymium. Global rare earth demand increased rapidly during recent years. In the view of Industrial Mineral Company of Australia, in 2020, applications in magnet account for about 23% of the total rare earth market share. According to International Energy Agency, in 2021, the usage of neodymium, praseodymium, dysprosium, and terbium in clean energy industry account for 14% of its total usage. By 2030, the demand of these rare earths for energy transition will reach to 34%, and also by 2030, 77% of its refining will be done in China. Rare earth permanent magnets are important for energy transition. There are 4 types of permanent magnets: ferrite magnet, aluminum, nickel, cobalt magnet, samarium magnet, and neodymium magnet. Neodymium magnet have the highest energy product. Its energy density is about 13 times greater than typical ferrite magnet by volume. However, its Curie temperature, which is the point where a magnet lost its permanent magnetism, is low, typically around 310 to 400 degrees. This is much lower than many other magnet materials. For example, samarium cobalt magnet Tc is 800 degrees. Without suffix, the maximum operating temperature for neodymium magnet is about 80 degrees. Above this, irreversible demagnetization can occur. But when alloyed with dysprosium or terbium, their heat resistance will increase. Depend on their applications. The working temperature of neodymium magnet could up to about 230 degrees. The common critical rare earths that increase heat resistance of standard neodymium magnets include terbium, dysprosium, and praseodymium. They promote the formation of a more stable critical structure, which increase the demagnetization temperature. Rare earth application in wind turbine not only in magnet needs, but also in alloy materials needs. Rare earth application in AI. Neodymium permanent magnet is used in GPU and GPU for optimizing energy efficiency. Yttrium is used for polishing optical component. Rare earth application in defense. One F-35 fighter jet need 418 kg rare earth. One Arleigh class destroyer need 2,600 kg. One Virginia class submarine need 4,600 kg. Rare earth application in EV include in motor and generator, in battery, catalytic converter, glass polishing, LCD screen, sensor, headlight glass. Rare earth application in F-35 jet include in engine system, in communication system, in avionics system, in navigation system, in alloy materials. Basically, almost all rare earth elements are used. Let's make a comparison. In Toyota Prius, about 1% of the total weight is rare earth. In F-35, its usage has reached 3% of the total weight. That's a lot.